Can you put miniature transformers on a semiconductor chip? Yes, it is possible to integrate miniature transformers on a semiconductor chip using various fabrication techniques. Transformers are widely used in electronic circuits to transfer energy between circuits, and their integration onto a chip can provide several advantages, such as reduced size, weight, and power consumption. One common method for integrating transformers on a semiconductor chip is to use microfabrication techniques, such as those used in the production of microelectromechanical systems, MEMS. These techniques involve depositing layers of conductive material on a substrate, patterning them using lithography, and etching away unwanted material to form the transformer structure. Another method is to use through silicon vias, TSVs, to connect multiple layers of a semiconductor chip. By connecting different layers of the chip, TSVs can be used to create vertical transformer structures, which can be particularly useful for high-frequency applications. Overall, while there are some technical challenges to overcome, the integration of miniature transformers on a semiconductor chip is possible, and has been demonstrated in various research studies and commercial products. Can you connect the miniature transformers in series or parallel? Yes, miniature transformers can be connected in series or parallel, just like their larger counterparts. When transformers are connected in series, the primary winding of one transformer is connected to the secondary winding of another transformer. The total voltage gain of the series-connected transformers is equal to the product of the individual voltage gains of each transformer. However, the overall power handling capacity of the series-connected transformers is limited by the power handling capacity of the transformer with the lowest power rating. When transformers are connected in parallel, the primary windings of multiple transformers are connected together, and the secondary windings are also connected together. This increases the overall power handling capacity of the transformers, as the total current capacity of the parallel connected transformers is the sum of the current capacities of each transformer. However, the voltage gain of the parallel connected transformers is limited by the voltage gain of the transformer with the lowest voltage gain. In both cases, it is important to ensure that the transformers are well matched in terms of their impedance and other characteristics to avoid any unwanted interactions or imbalances in the circuit. If the chip is made of silica carbide instead of normal silicon, will the miniature transformers have a higher input voltage, thus having a higher output voltage? The material used to fabricate the semiconductor chip can have an impact on the performance of miniature transformers, including their input and output voltage levels. Silicon carbide, SiC, is known for its excellent electrical and thermal properties, which can allow for higher voltage and power handling capabilities compared to silicon, Si, or other materials. SiC has a higher breakdown electric field strength than Si, which means it can handle higher voltages before breakdown occurs. This can enable the design of miniature transformers that can operate at higher input voltages, which in turn can lead to higher output voltages. Additionally, SiC has a higher thermal conductivity than Si, which can help dissipate heat generated by the transformers more effectively. Can you also make miniature inverters on a silica carbide chip? Yes, it is possible to fabricate miniature inverters on a silicon carbide, SiC, chip. Inverters are electronic circuits that convert direct current, DC, to alternating current, AC, and they are commonly used in a variety of applications, including power electronics and motor drives. SiC is an attractive material for power electronics due to its high breakdown voltage, high thermal conductivity, and high temperature operation capability. These properties make SiC devices ideal for high power and high temperature applications, where traditional silicon-based devices may struggle. There are several approaches to fabricating inverters on SiC chips, including the use of discrete SiC devices or the integration of SiC-based inverters on the same chip as other SiC-based components such as diodes or transistors. In both cases, the SiC-based inverters can offer higher efficiency and higher power handling capabilities compared to inverters fabricated using traditional silicon-based technologies. Overall, the use of SiC inverter technology is an active area of research and development, and the fabrication of miniature SiC-based inverters is certainly possible, although it would require specialized expertise and fabrication facilities. So, it's possible to line many miniature transformers in parallel and in series to get a higher output current and voltage? Is it also possible to power this chip from a miniature on-chip solar panel that is exposed, while the rest of the chip is covered? causing the chip to generate power? Yes, it is possible to connect multiple miniature transformers in parallel and in series to obtain higher output current and voltage levels. By connecting transformers in series, the output voltage can be increased while the output current remains the same. Conversely, by connecting transformers in parallel, the output current can be increased while the output voltage remains the same. Regarding the on-chip solar panel, it is certainly possible to integrate a miniature solar panel onto a semiconductor chip, which could generate power to drive the circuitry on the chip. This approach is known as energy harvesting, where energy is harvested from the environment, such as from light, heat, or motion, and converted into usable electrical power. Several materials and technologies can be used to fabricate miniature solar panels, such as amorphous silicon, organic photovoltaics, and perovskite-based solar cells. The specific choice of solar cell technology will depend on the application requirements and the available fabrication techniques. It is worth noting that the amount of power that can be harvested from a miniature on-chip solar panel will depend on several factors, such as the efficiency of the solar cell, the available amount of light, and the power consumption of the circuitry on the chip. Nonetheless, energy harvesting technologies such as miniature solar panels are becoming increasingly popular in low-power and Internet of Things (IoT) applications, where long battery life or battery-free operation is desired.